In the recent lessons before, we have been learning different ways to find congruent triangles, and in this lesson we're going to be learning the final way, which is SAS, or side angle side. Chapter 10. Understand the SAS procedure to find congruent triangles. Learning goals for today. Explore and correctly understand the SAS method for determining congruence of triangles. So being able to explore and correctly understand the SAS method for determining the congruence of triangles. Can use the SAS judgment method to prove that two triangles are congruent and perform simple applications. Understand that SSA cannot be used as a congruence condition for two triangles. So let's do a quick review. Review the first method of determining the congruence of triangles. The three sides correspond to the two equal triangles that are congruent, and that can be abbreviated as SSS. So all three sides of the two triangles are equal. So that would be SSS. This is just making it more complicated. So in this case, it would be two triangles, right? And then we know that all three of their sides are equal to each other. So then it would, right off the bat, we will know that they're a congruent triangle. Here's a geometric representation of that. In triangle ABC and triangle DEF, AB is equal to DE, AB is equal to DE, BC is equal to EF, and CA is equal to FD. So, this is a symbol for so. So, triangle ABC is congruent to triangle DEF, SSS. Think, are there any other judgment methods besides SSS? Well, when two triangles meet the three of the six conditions, there are four cases. The three angles are equal. Three sides are equal. Two sides, one angle, and two angles, one side. So we just tested out that if all three sides are equal, then it's a big check mark. We know for sure that those are congruent. But for three angles, we have a big X right here, because although in some cases if the three angles are equal, it could be a congruent, but not always. So we're going to put a no on that because we're not sure. And then two sides, one angle. Well, we're not sure about that, so time to find out. Finding congruent triangles, SAS. Question. Given the two sides and one angle of a triangle, how many possibilities are there for the positions of these two sides of this angle? So there's two triangles. We're given the two sides and one angle of the triangle is equal. How many different ways can we put this? There could be, this is the equal side, this is the equal side, that's the angle that's equal, that's the angle that's equal, or this one, or this is the angle that's equal, these two other sides that's equal. So this is one angle clipped by two sides, and this is two sides and one of the sides corresponding angle. So there's two different ways. Can you determine whether the two triangles are congruent? Exploration 1. Can SAS determine that two triangles are congruent? Now here's a DIY. Draw a picture of triangle A prime, B prime, C prime with a ruler. So that A prime, B prime is equal to AB, A prime, C prime is equal to AC, angle A prime is equal to angle A. Cut triangle A prime, B prime, C prime and place on top of it triangle ABC. Are they congruent? So I want you to draw triangle A prime, B prime, C prime with a ruler. And it has to be congruent to this triangle ABC right here. Okay? So what did you get? Here's the procedure. First, we draw triangle D, A prime E is equal to angle A. And then on ray A prime D, we split A prime B prime on AB. On ray A prime E, split A prime C prime is equal to AC. Then we connect B prime C prime. So here's how we do it. So first we draw that angle D, A prime E is equal to angle A. Then on ray A prime D, we're going to split off A prime B prime is equal to AB. So on AD, there's, with our compass, we're going to draw a crease from A prime right here with the length of AC. So what we're going to take is we're going to take our compass. It's this tool right here. Take the same distance from here and then place it over here, and we'll make this arc right here. Then we take the distance from A to B. I should use a different color for this. And then you use the compass to draw A prime B prime with this same distance right here. Using a compass, we'll make this crease, and then at the points where these intersect with the line, connect those 2 points, and then we get B prime C prime. So that's how we're going to get the congruent triangle. And if we place on top, this is not placed on top properly, but we place it on top, it's going to be equal. So think, is triangle A prime B prime C prime and triangle ABC congruent? How can you prove it? Which 3 conditions do these 2 triangles satisfy? Well, we know that A prime B prime is equal to AB. A prime C prime is equal to AC because we measured out the exact same length with the compass before drawing this arc, and that angle A prime is equal to angle A. So here's a knowledge point. The method of SAS. Text: 2 congruent triangles whose sides and one angle are equal, abbreviated as SAS. So notice that SAS is going to be an angle inside, an angle in between 2 sides. Geometric representation. In triangle ABC and triangle DEF, AB is equal to DE, angle A is equal to angle D, and AC is equal to AF. Must be the angle on both sides. So triangle ABC is congruent to triangle DEF, SAS. Exploration 2. Can SSA determine that 2 triangles are congruent? Think. As shown in the figure, fix one end of the 2 wooden sticks, one long and one short, and create triangle ABC. Fix the long stick and rotate the short stick to get triangle ABD. What does this experiment show? So, as shown in the figure, fix one end of the 2